Hello everyone. Today we will discuss about this. I will try to describe a simple neural network with a MATLAB code, and interestingly I wrote everything on a single whiteboard. Okay, I did it this way because this code has several parts, and for the beginners it will help them to connect everything together, and yeah, it may make you happy. That way it made me happy. Okay, the secret is I'm also new. Okay, let's start making this video. So let's go to our neural structure, like the architecture. Okay, so here you can see that we have just single layer, and x1, x2, and x3 are input, w1, w2, w3 are the weights, and you see the bias and the output. Okay, so actually what we are expecting from this neural network, how we will train this. So the thing is actually just we will give this inputs, and for each corresponding inputs we expecting these outputs. For example, if we give this input, we are expecting the output. Okay, like for rest of this the same. Okay, so how will this neural network should train itself? Like it will give output and try to match with the actual output. Okay, it will produce its own output, and then it will match with this thing. And after that, oh, by the way, one more thing. We have also MATLAB code. Okay, no problem, we will test it. Okay, just stay with me. So where I were, we will give this input, and it will calculate its own input output, and is compare, and you find mismatch, and you train itself again and try to perfect itself. Okay, that's the basic thing. Okay, let's go to the sections. So just see, this is a sigmoid function. You don't have to understand right now where it works. Let's just see. Okay, so just it's a sigmoid function is like this function, y equal to 1 divided by 1 plus e to the power x. Okay, so we just implement it in MATLAB like this. This is called activation function. Okay, actually this works in this region. So let's go to the directly training. Okay, and don't worry if you just what is he explaining, I don't understand that part. Just wait, we'll connect everything up. Just stay with me, man. And so this is our input, like the same input we showed you before, this thing. And this is the correct output. Okay, and this is the weight, and this is, just remember, this is a very important thing, because this is the main thing in neural network, kind of. Okay, not kind of, yeah, it's important, yeah, because it's doing the actual magic. So initially, how we'll calculate weight for training, we have to, okay, so to do that, initial we just introduce a rand function. What a rand function will do here, it will generate values between 0 and 1, and it will in a vector 1 1 1. Now it will create value like this, but between 0 and 1. And here what is we did, just multiply it by 2, so the value will be between 0 and 2, but we just subtract 1, so it will create -1 and 1. So this creates a random values, and this randomness is very important. We will get it later. Just stay with me. So each epoch, so this means that how many times we'll train our network. Okay, so I give the input of 10,000 times this will train. So how we'll train this is the main thing. We have to train the weight. Okay, so weight we will send to another training method. So we have a method like how we'll train this. So we send it to like SGD method, where it takes like weight from here, weight, okay, and then the input, this one, and the corrected output, and finally it will save. Just wait, it will save, we'll save later. So let's jump to like here. This is the method, okay. This comes from here and goes to there. So nice handwriting, okay. So weight equal to SGD method. So it is actually what it's doing. It takes weight input and correct output. Like this is the correct output, this is input. Okay. So and it trains them and gives it back as weight. Okay, that's the simplest thing you can think. Okay, let's see, simple. So only one there, man. Okay. So now what is alpha? We have another thing, alpha equal to 0.9. It's like the step size or the learning rate. Like if you are really far from being correct, or far from like, no, I'm not gonna use the like local minima, it's not like thing, but you think like you're really far from your optimal solution. So how in each iteration how far will go, this kind of things, how so this is the like learning rate or step size. Okay, you just Google it, you will find it. Okay, and then n equal to 4. I will start a for loop to train these things. Okay, so the question you may ask, why is n equal to 4? Because simple thing, you have 1 2 3 4 4 inputs. Okay, so we have to train each of them. So let's start. So for k equal to 1, we need to transpose the input. Okay, like you see that this thing is called the transposing. So why we need to transpose? It's also very simple, because you cannot feed this input directly to this neural network like this. You have to shift it, like this 0 goes to here. Okay, like you're shifting the thing, like it was like a row, like now you just take this thing and so now it can fit. Okay, so that's the simple thing. Okay, I'm saying okay too much. Okay, no problem. Okay, okay. So then we take the we assign the correct output in D 1 by 1, and then we calculate weighted sum. How we'll calculate weighted sum? As simple, we just multiply the weight, the randomly generated weight. Oh, wrong marker. Okay, so randomly generated weight, this weight, we get here, we just oh my god. Okay, sorry. So we just this thing multiply with the transposed input, and then we get the output. How you get output? We use this thing, we pass through this function like sigmoid, come here. Okay, so it like calculates the output, okay, using the activation function, and we come back again with our results. Okay, and then we calculate the error. What is error? This error is very simple, like it's error equal to D minus output. What is D? We already know the thing, corrected output, that thing. This is actually the D. We assigned it as D here. Okay, 1 by 1 it will like D minus output. What we just calculate with sigmoid, we find the difference, and then what we calculate? Delta is called gradient error. Okay, so how much the error? Okay, and actually it used in back propagation concept. Okay, so delta is actually a derivative of the sigmoid. Okay, you will find it, like just Google it. You'll find how they derived this from this. Okay, I don't want to waste time, but it's really simple. I know you know how to do derivatives. Okay, so we just calculated delta. Okay, now okay, I'll stop saying okay. Okay, okay. Then d weight. Then we calculate alpha into delta into transpose input. So we are the learning rate into delta, and delta just calculated, and transpose input, and this is how we are updating our weight with these things. Okay, so we just updated the weight, and then we have to like update each of the weight like with the previous one, like weight 1, like it takes then the weight, and because we have 3 weights, right? You see, W1, W2, W3, so definitely we have to update each of them, and it will update like 10,000 times, and then our training is done, and then we will save that in this file. Okay, our training is done, and now we'll test this. So when we test this, we just load that saved file here. Okay, this is the testing page, and we take the inputs, and we will give the same inputs for now, to expect that we'll get the same output, and n equal to 4 because we have 4 inputs, and then this loop, and it will train, it will check the results. So let's directly go to the MATLAB and see how our neural network works. Oh, my chair is really far. I hope you can see this. This is the sigmoid function. You can take screenshots. It's really small, really not that big. Okay, and like this is the training. Code, and this is the method we are training our neural network. See, okay, and this is testing. Okay, I will go to testing later. Let's just train this one. So run this. You see, it's training. So I hope it's the training is done already. Okay, the training is finished. Now we'll give the same input here to see that we get the output. What we're expecting, just remember, we're expecting to get 0 0 1 1. Hey, let's see what can we get. Oh, you see, we already have some outputs. Yes, but it's not 0. Don't be like disappointed. This is the reality, guys. This is almost 0 in if we think in this way, in this artificial neural network. It's like, yeah, it's quite 0 and this is close to 1. This is what we consider as that value. So we're just mimicking input and output, just same thing. Let's check is working or not, because the thing is, if we give each of this thing the same input, then it should give the same output. Like at the number 4 input, we give 1 1 1 1, so we'll change like this one too. You should also give give the same output, right? The last 2 outputs should be the same, in the next time, right? Let's see. Now let's see. You see, we have the same, we have the same like output for last two. So it train. If we give the same output each of it will give the same output. So yeah, our neural network is working. So that's it, guys. And if you next time we can next video we can make another one. It will be a little more like complex maybe. Okay, see you.